Almost live. There we go. Okay, here we go. Review day. So it is 3/12/2020. So number one, it says graph y equals x squared minus 2x minus 3. Okay, so let's put down what we know. To start off at the beginning, x, y axis, okay? Let's just do the easiest and we'll work our way from there. Okay, now right at the bat, when I look at this, I do know my y-intercept. My y-intercept is -3. Okay? Lawrence said if you let x equal 0, we'll get a y-intercept. If x is 0, I have 0, 0. So my y-intercept is going to be at the point 0, -3. Or it's just -3. We know that from other graphing we've done. So I'm going to put a point at 0, -3. Okay, there's one thing I can get pretty easily. Okay? Everybody okay with the y-intercept? It's just going to be the number by itself, because if that's 0 and that's 0, we're left with -3, right? Now, the next thing, let's think about this. So the next thing I can find is probably the vertex. Because it's in standard form, I'm going to have to use my favorite formula, which is -b over 2a, right? All right, so my a is 1, and my b is -2. So I'm going to do a -b. So I'm going to go -2 over 2 times 1. Okay, so I just plugged in my -b over 2a, which gives a positive 2 over 2, which is 1. So I know my line of symmetry is at 1. That's my line of symmetry is at x equals 1. Okay, that's my line of symmetry, x equals 1. Now, my vertex has to lie along this line. So to get the corresponding y value, I plug it in. So I'm going to go y equals a parentheses, and I'm going to go 1, just plug it in 1 right now, in for x. So I'm going to go 1 squared minus 2, plug in my 1. Oops, I want to use all the right colors. Minus 3, let's see, that's 1. Minus 2 minus 3 should be a -4 probably, I bet. I think that's -4. So I have a vertex at 1, -4. Okay, so then I can go ahead and put my 1, -4 right there. Okay, I've got a third point because of symmetry. I have a third point. So if I've got a point here, got to have a point. So where my pin is, got to have a point right there, right? Because of symmetry, have to have a point right there. Now, I can get the x-intercepts because those are called zeros. So I'm going to do that on my graph paper because I'm running out of room. So my x-intercepts are called zeros, right? And we've done zeros before because we know how to factor. So to get my zeros, we set y equals 0, x squared minus 2x minus 3. We've done zeros before. So if I factor, right, I'll have an x and an x. I'll go -3, positive 1. Everybody agree with that? If I factor it. So my zeros are at x equals 3 and x equals -1. I can put those point on my graph. So my zeros are at 3, 0, and -1, 0. Okay, what do you think? You can do all of this. We've learned all of this before. Not too bad. Okay, so then I'm going to go ahead and draw in my parabola. Nice and curvy, and I'm good to go. How's my pacing? We're going slowly enough?
Wait, in 3 dimensions, is a parabola just a cone?
Yes. You're going to do that in calculus. You're going to spin this around the axis of symmetry, and you're going to make a cone. Yes. And then we're going to do a bunch of calculus to find the volume of that cone. Okay, number 2. Okay, number 2, I like 2. I really like 2 a lot. Because 2 is already in vertex form, okay? So in number 2, it's already in vertex form. So on number 2, my vertex is at -4, -9, okay? So I'm going to go ahead and at least put that down on my graph. All right. Let's put down what I know. So negative 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, way over there. But that's my vertex, which means my line of symmetry. Just got to go right through that, right? There's my line of symmetry. Let me use a different color. Okay, there's my line of symmetry at x equals negative 4. Okay, so I've got my vertex. I have my line of symmetry. Now, to get the y and x intercepts, we're going to have to do a little bit of different math. But we can do that. So if we let x equal 0, right? So let's let x equal 0. So I'll use my equation, and I'll go y equal 0 plus 4 squared minus 9. So if I want to find a y-intercept, I let x equal 0. Okay, I can just do some math here. That's really 4 squared minus 9. 16 minus 9, which is 7, right? Okay, so I've got my y-intercept. Y-intercept is at 0, 7. Way up there on my graph. It's not going to fit. Oh well. I'll have to fold my graph back over and get it, okay? X-intercepts. Well, let's see. X-intercepts. If I let y equal 0, and I've got a x plus 4 squared minus 9, okay? And I will go through this. You know how to do this. You do. But I'm going to go through it slowly with you, okay? So before I do anything, there's going to be 2 of them. Would you agree with that?
Yeah.
There should be 2. So let me solve. I'm going to go first plus 9 plus 9. Okay. I'm going to get 9 equals x plus 4 squared. And then to solve this, let's square root it. Does that make sense? We take the opposite of a square, we square root it. Everybody okay with square rooting? So if I square root both sides,
3.
it is 3, but it's also negative 3. It's 3, and it's also, because I need, how many answers do I need?
4.
So I'm going to rewrite this as plus or minus 3 equals x plus 4, okay? Why plus or minus 3? 3 times 3 is 9, and negative 3 times negative 3 is 9. And we need 2 answers, don't we, right? Okay. Now, how am I going to get 2 answers from this? Well, there's 2 equations. There really are 2 equations. One is 3 equals x plus 4, and the other is negative 3 equals x plus 4. How am I doing? All right? Right? Does that make sense? And then solve. I go minus 4, I get negative 1 equals x. So that's 1 x-intercept at negative 1, 0. And the other is minus 4, I get negative 7 equals x, or negative 7, 0. And I can graph that. Go back to my graph, squeeze those points on here, and 1, 2, 3, 4, 5, 6, 7. Okay, now, there we go. And my y-intercept is off my paper, but I know it's there, right? How am I doing? I mean, this is stuff you know, right? You do. You know how to take a square root. You know there has to be 2 answers. That's why I did the plus or minus. Okay, ready? Swoop this way when you get it. Everybody good? Am I going too fast? Okay, I will wait. That's why I'm asking, okay? And, okay, number 3, easiest question on the test, I do believe. So, here's x squared. We're going to go 1 unit to the left. Okay, watch. To the left, horizontal, to the left. Which you think I'm going to the left, but I'm really going to the right. So, if I'm going to take my x squared, I'm going to translate it. I'm going to go g of x, because that's my new equation, parentheses x. Now, you'd think I'd go minus 1. Nope. You'd think I'd go minus 1, right? Nope. It's the opposite. It's going to be plus 1 squared. Don't forget your squared. Because it's the opposite of the inside. And we talked about the reason it has to be the opposite is because that negative one zeroes it out. And then we're going to shift down. There's your equation. Can you do that tomorrow? You have to remember, though, it's the opposite. So you've got your parentheses because it's inside quantity squared minus 3, okay? Now, what's the domain and range? Well, the domain should be easy. These parabolas, all these parabolas go forever, both directions, okay? So the domain is always going to be x equals all real numbers. I'll say it again. The domain on every parabola will always be all real numbers. I'll say it again. The domain on any parabola is always all real numbers. But, unless I fix the parameters. Then I have set parameters, yes. Smart guy. Now the range. Well, what's the very lowest spot on this graph? Negative 3. So it's y is greater than or equal to negative 3, because I know I'm going up. It's positive x squared, okay? Okay, number 4. So when I find the vertex, will that be a minimum or a maximum? Maximum because of the negative, right? It's got to be a maximum, I agree, because then we've got a negative. I know because of the negative x squared, it's going to look something like, I don't know, we haven't found the answer yet, but something like this, right? So that's got to be a maximum because of the negative. So let's find it. What's my special equation? Let's say it again. Negative b over 2a. So to find the vertex, x is equal to negative b over 2a, right? My b is 20, so my a is negative 4, and my b is 20. So let's go negative 20 over 2 times a negative 4, which is a 20 over 8, 10 over 4, 5 over 2, 2.5. How's that? Hopefully I did that right. Yes?
Why is the maximum?
Great question. Because of this negative here, it's going to be a frowny face. The parabola's got to go upside down, which means that top point, it's got to be a top point, not a bottom point. Right? So let me say it again. If this is negative, it's going to open down. It's going to be upside down, which means that vertex is at the top, which makes it a max, okay? If this is a positive, like these, okay, Laura, like this one, that would be a minimum, right? Okay, all right, let's go ahead. So I've got 2.5. Let me borrow my calculator back because I need the vertex. I'm going to plug it in. Let the calculator do the work, you guys. Honestly, let the calculator work. So I'm going to go, okay, y equals negative 4 times 2.5 squared plus 20 times 2.5 minus 6. And I'll try to make sure we have calculators for everybody tomorrow, okay? So just go let the calculator do the work, for crying out loud, because I will make a mistake, right? You've seen it. How many times have you guys seen me make a mistake? Lots. It's okay. I'm not offended. Let's try 6. I can do the math. 19. Okay. So my vertex is, and that equals 19. So my vertex is at 2.5 comma 19. How's that? How am I doing? Okay, 5. Honestly, do 5 by graphing. Take a moment to pull out a piece of graph paper. It can be done another way. But the easiest way to do it is just draw a picture. So on 5, let's see what I got. Okay, so I got a vertex at 3, 5. Okay. Okay. Graph the points, and then let's see if we can come up with a parabola. Okay. Okay. So what I'm going to ask is, where's the other point? Okay. So I've got a point at 3, 5. 1, 2, 3, 4, 5, and it passes through 6, 0. 1, 2, 3, 4, 5, 6. Okay. That's my vertex. Okay. Well, the other point has to be, let's see, this is right down the middle, right down the middle. There's my line of symmetry. It's got to be there because that's directly opposite. It's a reflection, so the other point's got to be at 0, 0. So I put 0, 0 in, I can graph this, right? So my other point's at 0, 0, and I can graph my parabola just like that. How's that? Does that make sense? If you draw a picture, it's pretty easy. All right, number 6, last but not least, all right? So, I'm going to throw a ball from a 20-foot platform. That's why the 20's there. Oh, no. This should be 10. This should be 10. I got to fix this. The 10's there. See, I did make a mistake. Told you. So, it's going to look something like this. And you're going to throw the ball up. Yeah.
Why on number 5 was your why was it upside down?
Great. So my .60 is here, right?
Yeah.
So the only way I can get from here to here is to draw it down. Does that make sense? Yeah. Good. I don't mind if you ask questions. It's a good question. Okay, back to this one. So I'm standing on a 10-foot platform, right? And I throw the ball up, and it's going to land. This is going to be time. 1 second, 2 seconds, 3 seconds. Okay, so find the time when so its highest height right here. That's the vertex, isn't it? Isn't that the vertex? Mm-hmm. So let's just find the vertex. So I'm going to use my negative b over 2a, right? And then I'm going to set up my negative 20 over 2 times negative 4.9, right? And hi, Gloria.
Hi.
Divided by, thank you, 2 times 4.9. So I get an answer of about 2.04. Okay? So the time, that's my time, 2.04 seconds. Okay. What's the height? We're going to plug it in. To find the height, I'm going to go h equals negative 4.9 times my 2.04 squared plus 20 times my 2.04 plus 10. I'm going to let my calculator do the work, honestly. Plug that in. I go negative 4.9 times my 2.04 squared plus 20 times my 2.04 plus 10, and the height is about 30.4 feet. Okay, so the height is about 30.4 feet. Okay, all right. Now, when does the ball hit the ground? You've got to set it equal to 0 and solve. And I'm not going to do that because that's the extra credit. And I'll let you figure out how you do that. So when it hits the ground, the height is 0. And I'll let you work on that.
That's extra credit?
That would be the extra credit tomorrow. Is find out when that hits the ground, okay? One is guess and check. The other might be factoring. Or the quadratic formula that your uncle showed you, huh? Yep.
Oh, that.
All right, now. Stop.